I really like this question. One of the reasons why is we're finally going to get into a domain that is restricted. In other words, there's no value for this red graph that exists past 3. Look, there's no red graph out here. Okay, so what does this mean? How does this affect the entire domain? Well, if you think about it, if we're adding things like we did here, right? That means if there's no graph out here, I can't add anything to this thing. So your new graph, h of x, doesn't exist out in this area. It just doesn't exist. Why? Because this thing right here restricts it. So the restriction on this domain applies to the restriction of all the domains in the combination. Wow, that's cool. Okay, so how do we do a question like this then? Well, okay, let's just do it. Let's just do this graphically. Let's start at 3. So the first one we want to do, h of x, which we're going to do in green, means we're just going to go out and we're going to start at 3, which is 0 and minus 1. So here we go. Let's go to 0 and minus 1. So 0 plus a minus 1 is minus 1. So our coordinate, of course, starts at 3. And our new coordinate of h of x is going to be 3 minus 1. So 3 minus 1. There it is. Okay, let's see if we can do this a little bit more efficiently. There is 1 and negative 2. 1 plus the negative 2 is negative 1. Okay, so at 4, we're back to negative 1. Oh, that's interesting. Let's find another one that looks pretty. I wouldn't use any of these values in here, but because they're not on a nice coordinate. They look ugly. Okay, let's find something that, look at that one. There's a nice coordinate there, goes with a nice coordinate there. So at 7, we're at 2, and what's this? Minus 5. Okay, so 2 plus a negative 5 is negative 3. All right, so, okay, this is at 7. We're at minus 3, right about there. Perfect. And then finally, is there any other one? No, not really. We can't see another one. So let's say that our graph looks like that. Well, we really can't get an idea what our graph looks like unless we go out and we actually plot this. So why don't we do that? Why don't we just throw this on the calculator to see what this thing actually looks like? Bring up the calculator here. Here we go. We got square root, second square root of x minus 3, and the other one is minus x plus 2. And let's graph this puppy. Let's see what it looks like. So there's our two graphs. Exactly what was given in the question right there. Perfect. Okay. Now, we want to combine those two. Go back to y equals 2. Go down to y3. Let's combine them. Alpha, is it 2 or 3 or is it 4? I can't remember. Let's try 4. Oh, it is. Okay. y1 plus alpha 4 y2. Boom. Okay, graph it. Boom. Looks very, very similar to what I have drawn right here. So obviously, this is just going to be a line that's going to go down like that. Interesting. Very interesting. Well, there's my h of x. But look at the question now. The question also says, give me k of x, which we're going to put in what color? Let's put it in black. Let's do k of x, which is f of x minus g of x. Now we can do the same thing. We can go back to our graph here and go, okay, all we have to do, if you think about it, is do exactly the same points that we had here. So here we go. There's f of x, there's g of x. Now we're going to subtract them. So this is going to be 0 subtract a minus 1. That looks like 1. This guy here is going to be 1 subtract a minus 2, which is going to be, well, okay, 1 subtract a minus 2 is going to be 3, right? This one out here is going to be a 2 subtract a minus 5, which looks like it's going to be 7. So at these points of 3, right, 3 is going to be 1, which is right here, okay? At 4, it's going to be 3, which is here. And then at 7, it's going to be 7. It's going to be right out here. So the graph looks like it's going to go in kind of this direction like that. Well, let's prove this. Let's go to our graphing calculator and actually see it. So notice that we've got everything still here. Now, let's shut off these graphs because I don't want to see them anymore. But I want them to be there. Okay, so let's get rid of them. Get rid of that guy, get rid of that guy. Now, let's go to Y4 and draw our new graph in purple. And remember, that is Y1, f of x, minus g of x. So, okay, alpha 4, there's Y1, subtract alpha 4, okay, Y2. Perfect. Graph it. Let's see what we got. Exactly what we had before. Isn't that interesting? That's very, very cool that the graphing calculator actually helps us to figure out these values. So we can figure these values out either graphically right by reading points right off the graph like this, remembering that all my x's don't change. They're the same x's, whether you're talking f of x, g of x, h of x, or k of x, the x's do not change. The only thing that changes is your y values and how you apply them. Are you adding the y values or are you subtracting the y values? That's what you got to remember.